All right, so I'm going to move forward. I've talked about the people side, the rules, all those kinds of things. I want to talk about decision support tools in a project that we did recently, and then we'll have a chance for some questions. Go through this pretty quickly. Over the years, we've developed about 11 front-end planning tools. I'm not going to cover all of them. In fact, I'm only going to cover like one. But you can do all this research, but if you don't take the research and put it into the field where people can use it, then what good is it? And we actually, I really ascribe to this term use-inspired research. In other words, we look at the problems, we do the research, and then we take it to the next step. So we developed 11 tools. I'm not going to spend a lot of time on them. We actually, in HTML process, we've looked at an overarching guide on how to do front-end planning. We've looked at alignment. We've looked at risk management, risk analysis during the front-end planning process, and so on. We've looked at renovation projects, what's different about a renovation project. We've spent a lot of time talking about the details of all those. The tools that are out there that a lot of people know about are the PDRIs, or Project Definition Rating Index tools. I don't know if anybody here heard of those or used those at all? Got a few that have done that. And over the years, we've developed 5 of those, a suite of 5 of them. One for commercial buildings, one for infrastructure type projects, one for industrial projects, and then small projects versions for industrial and infrastructure. Input of over 7,000 years of experience into those projects when we developed those tools. And that's one of the numbers I pulled out when we were looking at people who are involved in those industry-based teams to develop these tools, and then the workshops that we conducted to actually fill in the information. It turned out to be over 7,000 years. We haven't been building things very much longer than that, at least in recorded history. So a lot of experience went into these things, very much trying to get the industry knowledge and background. So I'm going to talk real quickly about a study that we're just finishing up. It's Project Definition Rating Index Industrial 5.0, so it's the 5th generation of the PDRI Industrial. PDRI Industrial was initially developed in 1996. It's focused on heavy industrial projects such as refineries, chemical plants, power plants, heavy manufacturing, and so on and so forth. And so we've combined maturity and accuracy, going back to making sure that we have a maturity and making sure that we understand and the environment our team is in to be successful. And I'll show you a few results from that. I'm not going to really spend a lot of time on this. We went out, as we always do in these CII and industry-focused research projects, we go out and get a lot of information, right? And so you can kind of read through this. We ended up with almost $9 billion worth of completed projects, and then another $5 billion or so worth of projects that used these tools in process. So we tried these out on a lot of projects, and we looked at them around the world. I didn't mention earlier that data that we've collected over the years has come from over 40 countries and 6 continents. So we've actually gone out and captured data around the world. So what I found is a lot of these truths apply no matter where you are on the planet. I'll just put this one up here just so you can kind of see. I mean, this is the input that we get in these development activities. You probably have worked with some of these companies or know of some of these companies. So there's a lot of input that goes in to developing any of these tools, which is kind of a neat thing for me because I get a chance to interact with people from all over the world and all over the industry looking at what is important in the front end. So anyway, one of the things that we looked at in this process was this idea that there's an engineering or design component in front-end planning, and then there is quite a bit of other things involved in the front-end planning process, and I'll illustrate this. This was our definition of a common term used in the industrial arena, which is commonly used in the wrong way, and we came up with an overarching definition. It's the work performed, front-end engineering design, or FEED. You'll hear the term FEED all the time. and everyone meant something else. So we came up with this definition. But I like to show it because this is the design component of what we're talking about in the front-end plan. That could be front-end architectural design. That could be front-end civil engineering design. But there's design that's kind of the cog in the wheel that we see here. It fits in with this front-end planning process. Usually in the detailed scope, we nail down a lot of these things about scoping the project, the design part, and it both informs and is informed by different things that make up the project definition package. So if I'm putting together a project definition package, i.e. the scope of a capital project, it's going to have the design, but it's going to have all these other things floating around it. The cost estimate is informed by the design is informed by the cost estimate. The schedule is informed by the design is informed by the schedule, and so on and so forth. And this is why it's really a complicated process. Because as we go through all of these things, we're trying to come up with the best idea that we can to move forward for a successful project. At the end, we're generally held to this success, to 2 or 3 success metrics. Did we meet the schedule? Did we meet the cost budget? Is it safe? And sometimes it deals with, how did it perform when we started it up? And this information really is the critical linchpin of making sure that you actually meet those performance indicators. If we have poor front-end engineering design, then many of the things that are listed here, like the work breakdown structure, cost estimate, and so on and so forth, is going to be in a situation where it's not terribly well defined. And that's one of the things that we see as we move forward. Out of this project definition rating 5.0, 46 of the 70 elements deal with engineering design. There's 70 total elements, so those other 24 elements deal with other areas of definition and maturity. This is an example of one of 70 of the elements that you have to look at to get a well-defined project for industrial. You'll notice over to the left there, that's the description of what we should do in terms of water treatment requirements for an industrial facility, including some comments. That's a new add to this. And then across this way really is the maturity. And so maturity level 1 means that we have done everything that we need to do from a scoping perspective on water treatment. Definition level 4 means that water treatment requirements are being identified. We have really just started what we should do. For all 70 of the elements that make up this tool, we've actually gone through and we've got a description of where you should be at the end of the front-end planning process. Where you should be at the end is at 1 or 2. The best available. If you leave things out, then you're not as mature as you could be. It doesn't mean you can't move forward. It just means the maturity level is not there as we move forward. So that's really the tool. There's a score sheet that goes with it. You rank this thing. It gives you a score that spits out at the end. And it tells you, number 1, is your design mature enough, your feed, in this regard. And it also gives you a total PDRI score, which is a lower score, that tells you is the entire scope definition package in good shape. So it gives you, or gives the user an indication, have they done enough or not enough. And that's really the basis of the PDRI, right? It's a decision support tool. It's a lot of choices. We have to make choices of how mature everything is and how much we're planning on moving forward. These are the top 9 industrial project maturity elements. If you've worked in the heavy industrial arena, these are very familiar to you. Each one of these, by the way, actually has a diagram that looks something like this. And that's the input of probably about 1,500, 2,000 years of experience that went into that. We also looked at factors that impact not only the maturity, but also the level of accuracy, the environment. Remember the hurricane? And so there are 27 of these. There are 4 types of factors. This is one of 27, the project leadership team accuracy factors. We also have a project team accuracy factors. We also have resource accuracy factors, and we have process accuracy factors. There are 27 of these. We evaluate each one of them. For instance, this one, we've got a description of what it is to the right. We evaluate it based on, is it high performing, meets most, meets some. Again, as a project team, I can go through this evaluation and I know where my gaps are, where I need to beef up my team, for instance, or where I need to do more work in the scope. Kind of nice. These are the top 5 factors. Some of these are probably pretty familiar no matter what kind of project you're involved with. Should read those for a second. You can kind of see them. And then we put all that into an Excel spreadsheet. And that's really kind of the tool in a nutshell. So kind of getting to the end here, what does this mean for you? And I could spend a lot of time, as I said, on a lot of these. But we go through the 70 elements. We look at the 27 factors. That gives us an indication of how accurate and how mature our scope is. We get a printout or a spit out, that's the maturity, the feed maturity, which is the engineering design maturity, and the accuracy. These are 33 projects, about almost $9 billion worth of projects, and you can see that we were actually able to measure maturity and accuracy and plot them in a matrix. Lower left, low maturity, low accuracy, not really a good place. We actually came up with hurdle rates in terms of maturity and accuracy based on statistical analysis of these projects. We found that those projects that were down in the lower left, on average, were 22% above their baseline budget. Not a real good place to be. Those that were high maturity, low accuracy, in other words, they had accuracy issues, but they had maturity, were 6% above budgets. A lot better. Maybe not where we want to be. And then we found that the high maturity, high accuracy were 2% below budget. So there's a 24% difference there. We also put in another $5 billion worth of projects, and we were able to plot those in that same form. So we have a way of measuring accuracy and maturity in that front-end plan, and that can lead to improvements and gap analysis as we move forward. So that's kind of the tool. So the research went from all this and came down to the details of how to get to the end. Oh yeah, so maybe we can identify what's wrong with the project a little better than we have in the past, right? In that regard.